we shall discuss that there are certain rules regarding how to draw the image of a object which is obtained by the spherical mirror. As such, these rules are not ever even asked in the examination, but for the understanding and to draw the image properly, the first rule is the ray parallel to the principal axis always will pass through the focus. Okay, so this is the first rule for the concave mirror. And if you have the convex mirror, then ray which is parallel to the principal axis, okay, here, okay, it will diverge, it will go away from the mirror, or it will diverge, and if you extend it in the backward direction, then it will pass through the focus. Okay, now the ray which is passing through the center of curvature of the concave mirror, or appearing to pass through the convex mirror, or rather we can say center of curvature of the convex mirror, if the ray is appearing to pass, then it will be reflected on the same path. You can see, okay, here the ray is passing through the center of curvature of concave mirror, and it is reflected back on the same direction. Okay, and here if you take the convex mirror, then if the ray is appearing to pass through the concave, rather center of curvature of convex mirror, then this is the direction of incident, then this will be the direction of reflection on the same path. Okay, now the ray passing through the focus or appearing to pass through the focus, then the ray after reflection becomes parallel to the principal axis. You can see this ray is passing through the focus of the concave mirror, and after reflection it becomes parallel to principal axis. Okay, and for convex mirror you can see this ray is appearing to pass through the focus of the convex mirror. Okay, if you extend, then it passes through focus, then after reflection it becomes parallel to the principal axis. Okay, now the ray incident at any angle at the pole, the reflected ray follows the laws of reflection. So if the ray is oblique ray, if this ray is oblique ray, then after reflection it subtends the same angle with the principal axis. So angle of incidence and angle of reflection will be same. Here also the oblique ray will follow the laws of reflection. Incident angle is equal to the angle of reflection. Okay, now there is mirror formula. Mirror formula you have studied in the 10th standard. Okay, this is the concave mirror, this is the object AB. Try to understand, this is the object AB. The ray parallel to principal axis, after reflection it passes through the focus, and the oblique ray will follow the laws of reflection. So both are intersecting at this point, and image is obtained at this point A prime B prime. Okay, so we can just see it. Okay, this is the way, this is incident ray, after reflection it passes through focus. This is the oblique ray, after reflection it intersects with the reflected ray which is incident parallel to the principal axis. So here this is the image A prime B prime. Now distance of object from pole of the mirror, distance of object is denoted by U. Distance of image, that is pole to B prime, this distance is distance of image or image distance denoted by V. Focal length is denoted by F, and radius of curvature, that is the distance between center of curvature to the pole, that is denoted by R. Now see the relationship, the derivation is not there this time. Okay, so the relationship between focal length and object distance and image distance is given by 1 upon f is equal to 1 upon u plus 1 upon v. And as you know, it is r is equal to 2f. So we can say 1 upon f is equal to 2 by r. So if you want to write this relationship between radius of curvature, object distance and image distance, then it can be written as 2 by r. 2 by r is equal to 1 upon u plus 1 upon v. So these are the equations that you should remember. Okay, and when you are using it, you have to understand and follow the sign conventions. The object distance, if the object is on left hand side, then we have to take it negative. Okay, this we must understand. So rules of sign convention you must follow when you are putting the values here in this equation. If the object is somewhere here, okay, then if object distance is say 30 centimeter, then you should take minus 30 centimeter. If image is somewhere here and object image distance is given say 10 centimeter, then it must be minus 10 centimeter. This way you have to follow, and then you can find the focal length or radius of curvature, whatever you want to find. And try to understand this point also, that when the concave mirror is there, when the mirror is concave, then focus is on left hand side, focus is here, then the focal length will be negative. And if you have a convex mirror, okay, then the focus will be on right hand side, then this focal length will be positive. Okay, so these things are very common that you have studied already in 10th standard, so you should keep in mind. Okay, another thing is that whenever you have a spherical mirror, say for example you have a concave mirror and the object is kept at infinity. These are all rules you have studied in 10th standard, just it is a revision. Okay, when the object is at infinity, then all these parallel rays after reflection will pass through focus, so its image will be formed at focus. This image will be real and inverted and highly diminished. Okay, and its magnification is very less, small, that is why it is minus 1. Magnification is the ratio of height of image, say height of image is h prime, to the height of object. And you have studied this, m is equal to minus v upon u for the spherical mirror. Okay, so magnification is height of image upon height of object, that is h prime upon h, and that is minus v upon u. Okay, now if the object is say slight far from the center of curvature, or we can say away from center of curvature, then its image will be formed between f and c. Image will be formed between f and c. If the ray parallel to principal axis is passing through focus, oblique the ray which is passing through focus, then after reflection it becomes parallel to principal axis. So both intersect at this point, and if you join this, then this image will be formed between f and c. This is real and inverted and diminished image. Magnification will be less than minus 1. Okay, minus means it will be a real image, inverted image. Okay, then object is at c, then the image will be also at c. The image will be real inverted, same height it will be having as that of object, but this is an inverted image. Therefore magnification is exactly minus 1. Minus sign shows it is an inverted image. Okay, now object position is between c and f. If the object is between c and f, then the image will be formed away from c. This will be a real and inverted image, magnified image. So magnification will be greater than 1. Greater than 1 means magnified image, and minus sign shows this will be an inverted image. Again you can see the ray parallel to principal axis, after reflection it passes through focus, the ray which is passing through focus after reflection, it becomes parallel to principal axis, and wherever they intersect we get the image. Okay, so this way you can easily understand. When the object is at focus, then its image will be at infinity. It will be a real and inverted image, highly magnified. Magnification is very much greater than 1. It's a inverted image, therefore it is very much greater than -1. Okay, when the object is between focus and the pole, and the image position is behind the mirror, virtual and erect image. Okay, when the object is here, the parallel ray, after reflection it passes through focus. If you extend it in the backward direction, then it will be somewhere here. Okay, the ray which is passing through center of curvature, then it will be reflected back on the same path, and if you extend it in backward direction, then they will intersect somewhere here and they form the image. Say for example, you have a shaving mirror. Shaving mirror is a concave mirror. If you place your face close to the shaving mirror, then you can see your image in the mirror, and that image is virtual and erect. Magnified image you will get, erect image is there, therefore magnification is positive. Okay, and magnification is positive means it's an erect image, and it's a magnified image, therefore magnification is more than 1. That is, height of image is more than height of object. Okay, now for convex mirror, the object is at say infinity, then all these rays parallel to principal axis. Okay, then after reflection they will diverge, they will go this way. Okay, and if we extend them in backward direction, then they will meet at focus. So the image which is formed is virtual and erect, and this is highly diminished image for convex mirror. Okay, and therefore magnification is less than 1. Highly diminished, smaller than the object, then magnification is less than 1, and if it is erect image, then this will be positive value. Okay, then any other distance, if you keep the object any other distance which is less than infinity, say for example you are using the rear view mirror in the vehicle, so the object is at any distance on the axis, then the image position between pole and focus, and on the other side of the mirror it will be, and it will be a virtual and erect image, diminished image, smaller than the object. That is why magnification is less than 1. In the it's a erect image, therefore it is positive. Again you can see the ray parallel to principal axis will be first diverge, and it will pass through the focus. Then the ray directed towards the center of curvature will reflect in the same direction. Okay, let me zoom it for you. Okay, you can easily see now. Okay, the ray parallel to principal axis, after the reflection, if you just extend in the backward direction, then it will pass through focus. The ray directed towards the center of curvature, then after reflection it will pass on the same path, but if you just extend in backward direction, then they will intersect somewhere here, and you get the image here at this particular point. And this is a smaller image than the object. You can see it's an erect image, so magnification is positive, and its value is less than 1. So positive shows it's a erect image, and 1 plus 1 magnification smaller than 1, then it is a diminished image. Okay, now we talk about the magnification. It's a ratio of height of image to the height of object. Now this figure you are very much known to you, this figure is very much familiar to you. Ray parallel to principal axis, after reflection it passes through focus, oblique ray, then it will be reflected at the same angle, that of angle of incidence, and the image is formed here. Okay, now we talk about the two triangles are taken, A prime B prime P and ABP. Okay, A prime B prime P and ABP triangles are taken. Just look into the figure. Okay, two triangles are taken. One is A prime B prime P and the other one is ABP. Okay, these two triangles are taken and they are similar triangles. Okay, so A prime B prime upon AB is equal to B prime P upon PB, it will be. Okay, now A prime B prime is nothing but height of image and AB is the height of object, so it becomes H prime upon H. Okay, and B prime P is nothing but image distance, that is minus V, and PB, you can see PB is an object distance, that is minus U. Now try to understand. This A prime B prime is below the principal axis this way. So we have to take this H prime negative. So 3 negative sign will give you negative sign. So we can say that H prime upon H is nothing but minus V upon U. And H prime upon H is nothing but magnification. So magnification is equal to minus V upon U. Okay, so magnification of spherical mirror, it is applicable to both. That is concave and convex. Mirror magnification is minus V upon U. Okay, so it is shown here. Magnification is minus V upon U. You can easily just write this much only, whichever I have written. Okay, and you remember the formula because all these things you have studied in your 10th standard. So no derivation will be asked based on this. Only the application and the numerical part is important for this particular topic. Okay, write this 2-3 times in your notebook. Okay, remember the different positions of object and the image formed because of those positions. Okay, 2-3 times watch this video. Okay, and write the necessary things in your notebook. Thank you very much.